Alright, welcome back to your favorite Calc 2 class, you guys. Up to this point, we've done some techniques with integrating specific rational functions, right? Like we know that's the natural log of u plus c, right? Or this one, our arctangent, right? We've done a couple of these, but we have not done a technique that does like 1 over x squared minus 5x plus 6. Now, I'm not going to run through this whole thing with trig substitution, but you could do this with trig sub, and frankly, it's a pain in the butt. It's quite the mess if you run through it, but it is possible to get there, right? But had you happen to know this, right? If you knew this is actually 1 over x minus 3 plus a negative 1 over x minus 2, then boy, that's a lot easier, right? Well, that's called partial fractions. You got to know how to get to that. And that's, in order to do that approach, we have to be able to find partial fractions. So we're going to do that today. And here's our little guide for decomposing into partial fractions. So the first thing, that number 1 there, is if you have an improper fraction. In other words, the degree of the numerator, so you have the degree of the numerator is 2 here, the degree of the denominator is 1. If the degree of the numerator is greater than the degree of the denominator, then the first thing you do is go ahead and divide it. So use your polynomial long division if it's an improper fraction. So let's do that first. So if it's an improper fraction, then divide. So we're going to go, okay, x squared minus 3x plus 1 divided by x minus 3. So what times x gives me x squared, right? And I say that'd be x. Now let me multiply it through. X times x, x squared, x times negative 3, negative 3x. Don't forget that we always subtract this, right? We're subtracting the whole thing. In other words, we're changing each of those signs. And notice negative 3x plus 3x, that's also gone. And so we're just going to bring down the 1. And so x squared minus 3x plus 1 is divided by x minus 3 is quotient plus remainder over divisor. And so we can rewrite this now, this integral. So step number 2, now that we've done the division, x squared minus 3x plus 1 divided by x minus 3 is quotient plus remainder over divisor. And now we can run it. So we have the integral of x dx plus the integral of 1 over x minus 3 dx. And of course, we'll let u be x minus 3, so du is 1 dx. So here we have x squared over 2 plus this will become 1 over u du. So the natural log of u and there we go. It's an improper fraction. So we go ahead and we divide, and then we use the tools that we have. All right, now let's take a look at this one. Notice the degree of the top is 1 x to the 0, right? So it's not improper. Let me note that. This is not an improper fraction. So the degree, again, improper is when the degree of the top is more than the bottom, right? So it's not improper. So what we're going to have to do is we're going to have to start partial fraction decomposition. It's called partial fraction decomposition by, number 1, we want to factor our the denominator. So right now we have this x squared minus 5x plus 6, right? That's the same as, if we factor that, we're like, oh, that would be x minus 2 and x minus 3, right? And let me come over here. So now we go to, let's continue. We're still working on partial fraction decomposition, it's called. But we're going to write this 1 over x squared minus 5x plus 6 as 1 over x minus 2 times x minus 3. Okay, equals. Okay, now let me go up to this guide for a minute. So we're doing number 2. We just factored our denominator, and it is in a set of irreducible factors, right? They're linear factors. So now I'm on to number 3 here. If I have linear factors and they're unique linear factors, then I set it up as a over the first one plus, and I'm going to use a b instead of that a2, b over the second one. They're not repeated, okay? So let me come back, oops, here. So I'm going to write this as a over x minus 2 plus b over x minus 3. Again, these are unique linear factors. And so I'm trying to find my a and my b. Okay, so if 1 over x minus 2, x minus 3 equals a over x minus 2 plus b over x minus 3, what is a and what is b is our question, right? Well, let's go ahead and let's multiply, let's clear out this denominator. We're going to multiply everything by x minus 2, x minus 3. Everything by x minus 2, x minus 3. And so we have 1 equals a, and notice the x minus 2's cancel there. X minus 3's cancel here. Okay, so we have this now. And now, this equation is true. 1 equals a times x minus 3 plus b times x minus 2. This equation is true for all x. In other words, any real number x. And so what we can do is we can substitute in convenient values of x to solve for a and b. Because we only have one equation. We have two unknowns, right? A and b that we're trying to solve for, but we don't have a second equation. And so let's just substitute in with convenient values of x. So what I'm going to do is I'm going to solve for a by letting x be 2. Can you see how if I let x be 2, it's going to clear this out right there? I'll have 2 minus 2 right there. So here, let's do it. 1 equals a, my x is 2. So 2 minus 3 plus b, 2 minus 2. Right? Again, I'm letting my x be 2. And you see how that's gone. Oops. See how that's gone? I got b times 0, right? So again, I'm solving for a by I'm picking a convenient value of x to solve for a. So 1 equals a times -1. Divide both sides by -1. Okay, so my a is -1. Now, let's solve for b. Well, if I'm solving for b, who's going to be my convenient value of x? 3, exactly. So I got 1 equals a times x minus 3. 3 minus 3 plus b. 3 minus 2, again, a times 0, that's gone. That's why we picked an x value to be 3 to solve for b. It looks like b is 1. So now, step 4, and remember, I'm using this. 1 over x squared minus 5x plus 6, which is x minus 2, x minus 3 dx, was a over x minus 2 plus b over x minus 3 dx. But we solved, remember we solved for a and b. Now we know A is -1 and B is 1. All right, so that's how you get to that partial fraction decomposition. So we don't have to use the trig sub like I said in the introduction, right, which is a total mess on this one. And then I'm just going to let u be x minus 2, so du is dx. And then I'll let u be x minus 3, so du is dx. So this just ends up being -1. The -1, put that in front. ln x minus 2 plus the ln x minus 3 plus a constant. Let me put this one first, and then let me subtract that. I have a little note here, you guys. Be sure you see this method, part of fractions, is practical only for integrals of rational functions whose denominators factor nicely, right? Like, if this denominator, instead of being x squared minus 5x plus 6, if it was x squared minus 5x plus 5, now that does not factor nicely, and this is way cumbersome with partial fractions. It's a total nightmare, right? So this is very nice factorable denominators. This one, actually, bless you, this one, the nice thing is it's already factored for us, the denominator, right? So the first of all, let's check. Well, is it improper? Well, the degree of the top is 2. If I was to multiply all these, I'd have an x cubed on the bottom, right? So this is not improper. And so now we can just go ahead and start doing our partial fraction decomposition. So partial fraction decomposition. Okay, so we've got x squared plus 4x plus 1 over. See how we have distinct linear factors again? And so we'll set it up as a over the first distinct linear factor, b over the next distinct linear factor, and then c over the last distinct linear factors. And then we gotta solve for a, b, and c with convenient values of x. And so what we'll do is we'll multiply everybody by, actually let me bring it over here. We'll multiply everybody by this, x minus 1, x plus 1, x plus 3. And see how it'll cancel that. So x minus 1, x plus 1, x plus 3. Everybody. So that'll be gone, that'll be gone, that'll be gone. So we have Alright, let's go ahead and solve for A. So if I'm solving for A, notice next to the B I have an x minus 1, and next to the C I have an x minus 1. So I'm going to let x be 1, and it'll clear out the B and the C. So I have 1 squared plus 4 times 1 plus 1 equals A times 1 plus 1, 1 plus 3. And again, see how that would clear that out with a 1 there, and that would clear that C out with a 1 there, right? So plus B times 0 plus C times 0. So I got 6 equals a times 2 times 4 times 8. Divide both sides by 8, so I get 6/8 or 3/4. Okay, there's my a. Now let's solve for b by letting x be -1. So I got -1 squared plus 4 times -1 plus 1. B. Again, notice the a and the c will be gone. -2 divided by -4. B ends up being a half. Solve for C. Notice the A and the B have an x plus 3 on them, so I'm going to let x be -3. That'll clear them out. Again, I'm using convenient values of x to do this, right? Alright, so there's our first step, was the partial fraction decomposition I solved with unique linear factors here. Distinct linear factors. So let's now that I know a, b, and c, this becomes, so I had this, and that was a over x minus 1 plus b over x plus 1 plus c over x plus 3. And it looks like I'll have no issues if I put the 3/4 in front. So I got 3/4. Again, let u be the x minus 1. So ln of u. Same thing here. Let the u be the x plus 1. So du is just the dx. Alright, this 6 problem, this is not a bad you try it problem. Notice it's, if you do want to stop it and try this on your own. Notice it's improper. The degree of the top is more than the degree of the bottom, right? I have an x cubed over an x squared, degree of the top bigger than the bottom. So the first thing you want to do with this improper fraction, it's improper, so let's go ahead and do the division. We've got 2x cubed minus 4x squared minus x minus 3 divided by x squared minus 2x minus 3. And so we're like, all right, what times x squared gives me 2x cubed? 2x cubed, that'd be 2x. And let's multiply through. 2x times x squared, 2x cubed. 2x times, now the next one, negative 2x would be negative 4x squared. 2x times negative 3, negative 6x. Don't forget, you got to change all these signs, right? Because we're subtracting down. So that's gone. Negative 4x squared plus 4x squared, that's also gone. It looks like I got negative 6, or negative x plus 6x, so I got a 5x. Bring that down, minus 3. So there's our quotient there. So I can rewrite this now as being step 2 quotient plus remainder over divisor. Okay. And so at this point, the 2x is not an issue. Let me split this up. This is not an issue, but this is still. This 5x minus 3 over x squared minus 2x minus 3. Now we know if we're going to have to do the partial fraction decomposition, which means I factor the denominator, right? Factor the denominator. So let me go to the side and do this partial fraction decomposition part. So we're trying to break this down. I have distinct linear factors, right? So I'm going to write a over the x minus 3 and b over the x minus 1. I'm going to multiply everybody by x minus 3, x plus 1. So I have 5x minus 3 equals a times x plus 1 plus b times x minus 3. We're going to solve for a by letting x be 3. And so my a ends up being 3. And then we're going to solve for b by letting x be negative 1. So my b ends up being positive 2. It's positive 2. So let me come back now down to here. So I've got the integral of 2x dx. That was not problematic. This, we had to do our partial fraction decomposition, right? And now we know a and b. So that becomes the integral of a plus b dx, right? Again, this is the same as this, right? It's our partial fraction. We had to do the algebra to figure that out in order to be able to integrate this thing. So we got 2x squared over 2 plus there we are. Notice this is not improper. The degree of the top is not bigger than the bottom, right? The degree of the top is 2, the degree of the bottom is 3. So let's go ahead and just jump into our partial fraction decomposition by factoring our denominator. So I'll take an x out. And then notice this is x squared plus 2x plus 1. That's x plus 1 and another x plus 1, right? So x plus 1 quantity squared. And so what we have is we have is not unique, right? In other words, I have a repeated linear factor here. I have 2 of these x plus 1s. Okay, and so if you go to the guide here, it shows you, let's see, where was that thing? Right here. If you have factors, repeated factors, you do a over it once, and then in this case I do b over it up to a maximum of whatever your degree is. Okay, so let me show you on this one. Let me erase this real quick. So a over dx, right? There's the one unique. And then I'm going to do a b over, and then I do this x plus 1, and then c over it up to the second. This is how it'll work for you, right? And then we're going to multiply everybody by x plus 1 quantity squared. So I have 5x squared plus 20x plus 6 equals a times, again, remember, I'm multiplying everybody by x plus 1 squared. X plus 1 squared, x plus 1 squared, x plus 1 squared. Everybody's being multiplied by that. So let's solve for a. If I solve for a, notice the b has an x next to it, the c has an x next to it. So I'm going to let x be 0. And that'll help me to solve for a. So 5 times 0 squared plus 20 times 0 plus 6 equals a times 0 plus 1 squared. So I got 6 equals a times 1 squared. So a is 6. Now I'm going to go ahead and notice the a and the b both have an x plus 1 next to them. So I can solve for c by letting x be negative 1. So a will be gone, b will be gone. So negative 9. C ends up being 9. Right? And there's not a convenient. Notice the a, like to solve for b, right? There's no convenient x value to plug in for, right? To solve for b, but I could do a and I could do c, and now I know a and c. So I just use that fact that since I know a and c, we know a is 6 and c is 9. So now it's not a problem even though there's no convenient value for x. So I could just pick any x that I want. So let's just pick x being 1 and it'll work for us because I'll just be down to b. All right? So 5 times 1 is 20. A is 6. C is 9. Yes, 6 times 2 squared. 6 times we got 24. B times 1 times 2, I get 2b plus 9. Subtract 33 from both sides. Divide by 2 to solve for b. There's our b. b is negative 1. So finally, this becomes step 3. Or, so I'm going back to this here, right? Now that I know a, b, and c, I can set this up as a over x. So 6 over x plus b over the x plus 1 plus the c over x plus 1 squared. And so we've got so 6 natural log of x minus natural log x plus 1. All right, I'll let u be that x plus 1. Now here, notice when I let u be and du is dx, right? So I have 9 1 over u squared, or u to the negative 2 du, right? So I got 6 natural log of x minus the natural log of x plus 1 plus 9. Now it's u to the negative 1 over negative 1. Make sure you replace u, of course. So minus 9 over u. Well, our u is x plus 1. If you wanted, you guys, you could write this. Remember, n ln of u is ln of u to the n, right? Remember that rule? So this would be like ln of x is 6. And then remember this rule, ln of u minus ln of v is ln of u over v. So you could write this as the ln of absolute value of x to the 6 is also absolute value of x to the 6. These would be the same. Either of those would work. Alright, how about you guys try? This is a repeated linear factor on this one. In other words, if you were to factor this denominator, and by the way, notice this is not improper. Right? I got x plus 2, x plus 2. So go ahead, pause it, and set that up. Do partial fraction decomposition, see how you do. The partial fraction decomposition of this with repeated linear factor, right? You get 2 of these x plus 2's, as we say, it's a over it, and then b over x plus 2 squared. And by the way, if this was to a third, x plus 2 quantity cubed, then I'd do a c over x plus 2 to the third, right? If it was to a third, but it's not. So you go up to how many you have there. Right? Multiply everything by x plus 2 quantity squared. So we got 6x plus 7 equals ax. 2. Let's go ahead and distribute that. In this case, and then here, what I'm going to do is notice your bx term, ax term, if you will. 6x must be equal to ax. So you see how a's got to be 6? All right, the coefficient there. And then over here, your 7 has got to be equal to 2a plus b. But we also know, note, we already know a is 6. So when we have the constant equal to the 2a plus b, right? 2a plus b, we don't have any x's involved there, right? So the 7 is equal to that constant, or 2a plus b has got to equal to that constant 7. But we got to know that a is 6 to find that b, right? So 7 equals 12 plus b, subtract 12 on both sides, negative 5 equals our b. And so now we're at the point where we're like, all right, this 6x plus 7 over x plus 2 quantity squared dx, which is a over x plus 2 plus b over x plus 2 squared. Now that we know a and b, oh gosh, now we know a and b, a is 6, b is negative 5. So that's 6. Natural log x plus 2. Again, let u be x plus 2 minus 5. Let u be x plus 2, so du is dx. So we got minus 5, and then we're integrating u to the negative 2, which is u to the negative 1 all over negative 1, right? So it'd be negative 5x plus 2 to the negative 1 all over that negative 1. So before we get into quadratic factors, up to this point we've done linear factors, right? If we have distinct linear factors, we just set it up as a over the first one plus b over the next one, and so on, right? If it was repeated, we did it like this one, right? A over the factor plus b over it twice, and so on. Now with quadratics, and then of course we used convenient values of x, right, to solve it. There's really no other way than to use systems of equations. Okay, so we're going to have to do systems of equations when we have quadratics. But let's go ahead and look at this first one here, make sure we can at least get the setup correct, and then we'll talk about using systems of equations to solve this. So number one, note the degree at the top is 3. If I was to multiply this out, the degree of the bottom is 4, right? Degree of the top is less than the bottom. So this is not improper. I don't have to do any division before I start this problem. I don't need to divide the polynomials. So I can immediately go into partial fraction decomposition. So number one, let me factor this completely. So I'm going to take an x out of that. And then x squared plus 4, I've got no issues, or nothing I can do there, right? That's as far as I can factor. X squared plus 4 doesn't factor any further, right? So this will set up with a over x. X is just a unique linear factor. B over that next unique linear factor. Now, notice this. This is a quadratic factor, right? So when you set this one up, what you do is you put a linear on the top, cx plus d over that quadratic factor. So cx plus d over that x squared plus 4. Okay? And then we're going to go ahead and multiply everybody by x minus 1, x squared plus 4. So we'll have 2x cubed minus 4x minus 8 equals a x minus 1, x squared plus 4 equals bx x squared plus 4 plus cx plus d times x and x minus 1. And let's go ahead, I can solve for a by letting x be 0. And so I'd have 2 times 0 cubed minus 4 times 0 minus 8, so I'd have negative 8. So negative 8 equals a times negative 4. So a ends up being 2. I can solve for b by letting x be 1. So b ends up being negative 2. And now note I have c and d, right? And so to solve c and d, I'm going to need 2 equations because I have 2 unknowns, right? I'm going to do this with systems of equations. And so we know a is 2, b is negative 2. Let's go ahead and let's let x be negative 1. And let me call this equation 1. Okay. And I'll have my first equation. And then I'm going to do an equation 2. since I know A is 2, B is -2, I've already used 0 for x, 1 for x, and -1 for x. How about let's let x be 2 this time. And now I'll have a second equation. So I'll have 2 equations, and I'll be able to solve for C and D on these. Okay? We got 2 times -1 cubed minus 4 times -1 minus 8 equals A is 2. Plus B plus C x plus D so we've got, that'll be -6 10 to both sides, so 4 equals -2c plus 2d. We divide everybody by 2. Okay, there's my equation 1. Now I'm going to let x be 2. Get my x up here, so 2. Plus b times x squared plus 4 plus c times x times x times x minus 1. So we got, let's see, 0. I did everybody by 2. Alright, so here's our 2 equations and our 2 unknowns, right? I've got this one, I've got that one. So let me solve this. I'll call this step 2. Let me write, here's this one. Here's the next one, let me put it right. Let me do this by elimination. Alright. Notice if I add them up right now, I'd have 10 equals C plus 2D, right? That gets me nowhere. So I got to eliminate them. So I'm going to multiply this top one by -1. And that would be -2 equals C minus D. This bottom one stays the same. So again, I'm using linear combination or elimination approach, right? So I got 6 equals 3C. -D plus D is gone. I divide both sides by 3, so my C ends up being 2. And now that I know my C is 2, I could take either of these. 2 equals -C plus D. I'll just take that first one. Add 2 to both sides. So it looks like my D ends up being 4. And so finally we can set this thing up, right? I've got back up to here. use this with my A, B, and C. All right. So I've got the integral of A. What was my A? A was 2. A over X. And then I had B over X minus 1. B is negative 2. And then I had the CX plus D. CX plus D over that X squared, that quadratic factor. Okay. And so this will, let me rewrite this as the integral of, this one won't be an issue. This one won't be an issue. But then let me write this as 2x over x squared plus 4, and then a separate 4 over x squared plus 4. That's how I'm going to have to, whoops, that's how I'm going to have to do this. So this goes to 2 natural log x minus 2 natural log x minus 1. I'm going to let u be x squared plus 4, so du is 2x dx. So that's just 1 over u du. So that'll be the natural log of x squared plus 4. And then over here, my u is x squared plus, hold on, that's going to be, oh, I'm going to have to use the arctangent on this. Hold on, so let me write this last one like this. My x is being squared, x squared plus 4. Alright, so that's the one I'm looking at now. So, well, if you remember, this is where, look at your formula sheet, and you have 1 over u squared plus a squared du is 1 over a arctangent of u over a, if you remember that, plus a constant, right? So that's what I'm using. This is my u, this is my a. This was one of those integration formulas we had in Calculus 1. So you got plus 4, and then it's 1 over a arctangent of u over a plus a constant. Almost there. All right, notice the degree of the top's 3, the degree of the bottom's 4. This is not improper. We can go immediately to our partial fraction decomposition. So we have 8x cubed plus 13x over x squared plus 2. Notice x squared plus 2 does not factor anymore, right? So this will be a quadratic factor, but it's not a distinct one. I got 2 of these x squared plus 2's, right? So I'm going to set this up as ax plus b has got to be my numerator over the x squared plus 2, but it's a repeated one. So I got to do a cx plus d over that x squared plus 2 squared. That's how we're going to set this up. Okay, it's a repeated quadratic. It's a repeated quadratic. Multiply everybody by x squared plus 2 quantity squared. So I got ax cubed plus 13x equals ax plus b times x squared plus 2 plus cx plus d. Notice that x squared plus 2 will factor out. Now let's go ahead and FOIL this thing. That's a B. That's just a really bad B. And then let me write this as 8x cubed. Notice there's no x squared term. Then I got 13x, and there's no constant either. And over here, I'm going to write it in descending order here. I got 8x cubed, ax cubed, sorry, bx squared. And notice I got 2ax and a cx. So what I'm going to do is I'm going to factor an x out, and I'd have 2a plus cx. So that's my blank x term, right? And now on the end, I just have my constants. Here's my constants on the end. 2b plus d, right? There's no x's involved there. That's my constant. So now I can say, well, 8x cubed equals ax cubed. So my a must be 8. And then 0x squared equals bx squared. So my b's got to be 0. (13x) equals 2a plus cx. So 13, I'm just going to take that 13 and set equal to 2a plus c, right? Because that's what 2a plus c must be equal to. But remember, we already know a is 8 and b is 0. So that'll help us there. So c ends up being -3. And now 0 equals 2b plus d. 2b plus d equals 0. Again, we know a is 8, b is 0, and we also know c now. C is -3. So 2 times 0 plus d. Looks like our d ends up being 0 on this. And so now we can set it all up. And I'm coming back to this right here. I can set this up now that I know a, b, c, and d. So the integral of 8x cubed plus 13x plus 2 squared dx, same as a is 8, ax plus b over x squared plus 2 plus cx plus d over squared plus 2 squared. And so we've got 8 x over x squared plus 2 dx and minus 3 x over x squared plus 2 squared dx. And let me let u be x squared plus 2. So I need a 2x, so I got to offset it with 1/2. Over here, I'm going to let u be that x squared plus 2. So it also needs a 2, which means I got to offset it. Fine. So we have 4 integral of 1 over u du minus 3/2. That'll be 1 over u squared du. So u to the -2 du. So we got 4 natural log of u minus 3/2, and then u to the -1 over -1. So x squared plus 2 to the -1 over -1. All right, let's set this one up here. We've got, notice the degree of the top's 1, degree of the bottom's x to the 4. This is not improper, so we're going to get right into partial fraction decomposition. Can't factor that anymore. Now I've got this repeated linear factor. So let's account for the quadratic factor. So I'll have ax plus b over this distinct quadratic factor. Now my x minus 1 squared, that's a linear factor, but it's repeated. So I'll have a c over it and then a d over it squared. And now we multiply everybody by x squared plus 1x minus 1 quantity squared. And so we'll have negative 2x plus 4 equals ax plus b times x minus 1 squared plus c times x squared plus 1 x minus 1 plus d times x squared plus 1. Minus 1, x minus 1, I got x squared minus 2x plus 1. I got x cubed minus x squared plus x minus 1 plus 2x squared plus d. Let's see. So we've got, let's see here, let me, on my x cubed, let's see, here's an x cubed, here's an x cubed, so let me factor out a plus c x cubed. Now let me go to x squared. Here's an x squared, here's an x squared, and here's an x squared. Oh, here's, oops, I missed that one. And that one also right there. I think I got all my x squared. So let me factor out of the x squared. So I would have negative 2a plus b plus c, I'm sorry, minus c. Gosh. Minus, come on. Minus c plus d x squared. There's my x squared. I better do a different color here. All right, x terms. There's an x term. There's an x term. There's an x term. So I've got a minus 2b plus c are my x terms. And then my constants on the end will be the b minus c plus d. There's my constants on the end. All right, so let's set this up now. We've got, you see this negative 2x plus 4? That's like 0x cubed plus 0x squared minus 2x plus 4 equals this stuff, right? So all my 0x cubed lines up with the a plus cx cubed. So my equation 1, my coefficients of x cubed would give me the equation 0 equals a plus c. My equation 2, my coefficients of x squared, right? So that's, let me do it in red. 0x squared lines up with this negative 2a plus b minus c plus d. So 0 is the coefficient. Negative 2a plus b minus c plus d. Let me go to coefficients of x now. Well, the coefficients of x is that -2, right? -2x. And let me do it down here. -2x. That lines up with this one. So -2 equals a minus 2b plus c. And then finally, my coefficients of x to the 0. In other words, the constant on the end. Well, the constant is 4. So that equals b minus c plus d. Okay, and so what I'm going to do now is I'm going to use, 2 and 4. Equations 2 and 4. So 2 is and I do that because see how the C's and D's will, if I can multiply by -1, see how they'll cancel? So I'm going to multiply this by -1. So this will become -4 equals -b plus c minus d. See how those are gone. And so I got -4 equals -2a. And I divide everything by -2, so my a ends up being 2. And so now I know a is 2. And so since I know a is 2, I'm going to go ahead and just use equation number 1. 0 equals a plus c. So I got 2 plus c. So now I know c. And now I know a is 2, c is -2. Let's use 3, because I'll have a and c. I'm going to use equation 3. So b ends up being 1. And so now let me come up here. Now I know a is 2, c is -2. I also know b is 1. Let's use 4. 4 will give me e minus c plus d. 4 will give me the d. So that 4 equals 3 plus d. D ends up being 1. Alright, so now let me, gosh, I'm kind of running out of room here on PDF this. Let me come up here. So we've got this 2x plus 1 over x. Hold on. Sorry. Let me show you where I'm at. I'm using this. Right, I'm rewriting. So now I got ax plus b. A is 2, so I got 2x. Oops, I don't want that. Let me do it black. Plus b. B is 1 over my x squared plus 1. Plus, and then I have a c. So I got -2 over that x minus 1 plus d. D is 1. I'm going to break this up into 2x over x squared plus 1 plus 1 over x squared plus 1. And so we got the natural log x squared plus 1. This is my u, oops, let me do that different color. Come on. There's my u. There's my a. So it'd be 1 over a arctangent u, whoops, which is x, over a. And then we continue on with this. Minus 2 natural log x minus 1. And then we're integrating 1 over u squared. So I got plus u to the negative 1 over negative 1 plus a constant. So we got the natural log x squared plus 1 plus the arctangent of x minus 2 natural log x minus 1 plus, oops, minus 1 over x minus 1. There it is. Alright, good time to pause the video, give this one a shot. Notice it's not improper. And so when I run my partial fraction decomposition, it'll be a over that first. That's a distinct linear factor. And then I've got this quadratic factor, but it is repeated. So I have a bx plus c linear form over it once, and then dx plus e over it to account for the second, to account for it being a repeated quadratic factor. Multiply everybody by x plus 120 squared. And so you got 1 equals a x squared plus 1 squared plus bx plus c times x squared plus 1 plus dx plus e times x. Let's see, plus. Alright, here's my x to the 4th. So I got a plus b x to the 4th. I think this cx cubed is my only x cubed. And then, let's see, x squared. Here's an x squared. Here's an x squared. Here's an x squared. So I got 2a plus b plus d x squared. And then my x terms, so cx and ex, so c plus ex. And then I just have my constant on the end, which is just the a, looks like. There's my constant on the end. And so we've got coefficients of x to the 4th, right? It's 0x to the 4th plus 0x cubed plus 0x squared plus 0x plus 1, right? That's my left-hand side of this equation. So 0 is the coefficient of x cubed, so that would line up with that a plus b. My coefficients of x cubed would be 0 equals c, so now we know c. My coefficients of x squared would be 0 being 2a plus b plus d. My coefficients of x would be 0, so c plus e. And then I have my constant. So my coefficient of x to the 0, that's the 1 equaling dA. So I know my a is 1. All right, so I know right off the bat, c is 0, a is 1. That's nice. So we know a is 1. I know c is 0. Let's go ahead and use, let's use number 1. And so my b is -1. And so now a is 1, b is -1, c is 0. Let's go ahead and use 3. So my equation 3, 0 equals 2a plus b plus d. So my d is -1. And now we know a is 1, b is -1, c is 0, d is -1. Let's go ahead and use 4, which is 0 equals c plus e. So it looks like our e is 0. And so now we have, let me come back up here, and I'm coming back to this, right? Now I can set it up. I've got step 2 here. A over x, or a was 1, over x, plus bx plus c. So I get -1x plus c over that x squared plus 1, plus dx plus e over squared plus 1 squared. So we got 1 over x. Let's see, minus x over x squared plus 1 minus x over x squared plus 1 squared. Let u be x squared plus 1, so du equals 2x dx. 2x, gotta offset it. Same thing over here. So this ends up being the natural log of x minus a half natural log x squared plus 1 minus a half, and this is the integration of u to the -2. So I got u to the -1 over -1 plus a c. You know, I'll go that a little bit further. Well, or if you want, that's always positive, so on that absolute value, it's to the 1/2. That's the same thing as well. And just a couple notes at the end here. A few things you should remember. Number 1, it's not necessary to use it on everything, right? Like this one is not an appropriate, because if I just do this with u substitution, where I let u be this x cubed plus 3x minus 4, I can do this. That'll work for you. Number 2, sometimes when you factor it, like if you factor on this second one, so that's note number 1. Number 2, maybe it's not in reduced form, and so yeah, I know there's actually a hole in this rational function, but I can still go ahead and it behaves like the simplified form, and so I can properly still run the integral. And then also sometimes you can use partial fractions when you're involving transcendental functions as well. So if you let u be sine x over cosine x, this would be, u is the sine, du is the cosine. And so this ends up being 1 over u times u minus 1. And you could set it up this way. Just make sure you plug in your u at the end, and you could solve that. And this one will actually end up being, that'll actually work out for you. But thanks so much for watching. See you guys next time.